Hello students, in this video I am going to discuss about clamper. So clamper basically is a device which is being used to clamp an AC signal to a specific DC level. So it is being designed with the help of a diode and a capacitor and resistor. So here you can see that we are having a capacitor, a diode, a resistance, and we are providing input from this terminal and we are getting output across this terminal. So what is the major functionality and how it works is very important, and that it actually does not do anything with respect to the shape as in the clipper. In clipper, some of the portion is being eliminated as per the requirement, while in clamper the shape of the device input remains unaltered at the output, while the only level is being changed. So that is all about your clamper. So this is an example in which this particular input, which is a square wave input ranging from 1 to -1 volt, and it is having 3 cycles. So we are applying it at this particular input and we try to get it at this output. So now, as we already know, this is a diode, and when we talk about diode, then diode can be ideal, it can be practical. So here we assume that diode is ideal. So it does not have any drop. So in case of ideal diode, your resistance of diode is also equal to 0. So when this is forward biased, this resistance is parallel to this resistance. So this is acting as short circuit, so no resistance is there. So RC is 0. So that means your time constant is 0. T is equal to RC is equal to 0. So that means it does not take much time to charge, it will charge at once. Now, we are using these assumptions in this explanation. So when you are actually applying this positive input, what happens? This capacitance will be charged like this. And this diode and this is actually shorted. So no voltage is there. So we are getting voltage as 0 here. Now, once again, you are applying this input. So this input will charge this capacitance. This will also forward bias this diode. So when diode is forward bias, its resistance is in this case, this is ideal. So this is equal to 0. And R is the resistance. So resistance into 0 parallel to 0 resistance is 0. So that means this is short circuit. So there will be no voltage here. These two terminals are short circuited. So voltage is 0. Now, when negative cycle is there, then this diode is reverse biased. Negative cycle means plus, minus. But in the previous cycle, this is being charged. So when we look from here into this terminal, what we will find that minus V is there and minus V is there. So overall voltage V out is equal to KVL you apply in this direction. So you will getting minus V plus minus V is equal to -2 volts. So this is being illustrated here. So what we have observed in this particular diagram, that this is the input we are applying and this is the output we are getting. The only thing which is changed is the level of the input has been clamped. So that's why it is called clamper. So this is the case when diode is ideal. Sometimes diode is not ideal. Then what happens? So we will be discussing that scenario in the next example. So this is the circuit. This is 2 volts. So in this case, this is not an ideal diode. That means it is having a voltage drop of 0.7 across this. And this is the waveform we are actually applying. So diode voltage is 0.7 is given and diode resistance is 0. We have to find out the output voltage corresponding to this input voltage your input voltage in the positive cycle, it is 20 volts. In the negative cycle, it is minus 5 volts. It is plus 5 volt, 20 volts. And here it is minus 5 volts. So your input is like this in the cycle. Now, we are making assumption here now before coming to the things. Now, this diode need to be converted into the equivalent model. So here you can see this 2 volt is being written as it is. This diode is being represented by a voltage source and your ideal diode. Now, what happens? We start working after this conversion. So what we have done, we have positive voltage here being applied at this particular moment. So this is your 20 volts. So this goes like this. So this is being applied here in this particular fashion. So now they are in series. So overall this voltage becomes at this particular point, say this point to be A and this point to be B. This point to be B. Now what is the overall voltage? 22.7. At point A, your voltage is 22.7. At point B, your voltage is 0. So what is the voltage, effective voltage at this particular point B is minus 22.7. So that means this diode is reverse biased. So it will not conduct. So correspondingly, for this particular input, you are not supposed to get any sort of output because diode is reverse biased. So here you can see you are getting output like this for this particular moment. Now, when this input moves from positive cycle to negative cycle, here you can see this is now minus 5 volt. So now this entire thing remains same. The only thing changes is this, that now we are having minus 5 volts, minus 5 volts. Now this is opposition to these two voltage sources. So minus 5 and 2.7, they are opposing each other. So it becomes minus 5 volts and this is 2.7 volts. So this becomes 2.3 volts minus 2.3 volts at this particular point, and point B is 0. So point B is 0, this is minus 2.3, so that means B is more positive as compared to A. So that means this diode is forward biased and it will conduct. So when it will conduct, whatever voltage at this particular point will be reflected at the output. So at this particular voltage, the voltage is minus 2.3. So you will get a voltage of minus 2.3. So this is the thing. That means during positive half cycle, diode is not conducting, and during negative cycle, you are getting voltage of minus 5 volt plus 2.7 minus 2.3 volts, and your output is minus 2.3 volts, and your output waveform is like this. For positive half cycle, you are not getting anything. For negative high cycle, you are getting minus 2.3 volt. So in this way, we can discuss any circuit based on our knowledge about various components, passive components like resistance, inductance, and capacitance, and active components like diodes. So I hope you enjoyed the learning. If you have any doubt, you can email me or you can ask questions in the comment box. Thank you very much. It is acting
Series
as a
connection.
series connection. Yeah, this is series connection. So this is 20 volts. This is 2 volts corresponding to the battery given in the question. And this diode is not a ideal diode. This diode is not a ideal diode. This is a practical diode. So we have substituted here your constant voltage drop model. So we are putting here 0.7 volts diode here. battery here, and this is your diode. So this becomes 20 plus 2, because positive, negative, and negative, you might have seen in their at homes, that if battery are connected in series, then negative, positive, and something like that. Yeah, negative, positive, negative, positive, negative, positive, negative, and so on. So they are in series. So this is now 22.7 volts. 22.7 volts. Now 22.7 volts is at N side. Is at N side of the diode. So at this N side, you are having 22.7 volts. On P side, you are having 0. So that means your diode is reverse biased. So if diode is reverse biased, it is not going to conduct. So if it's not going to conduct, you are getting no output. You are getting 0 output. Now, when it becomes negative cycle, now -5 is there. So -5 is like this. -5 is connected to this. So now -5 is opposing these two batteries. So -5 minus 2 points plus 2.7 becomes -2.3. So that is why you are getting here -2.3. So I hope now doubt is clear.